Well, I mean, if you guys are good, no questions, we're just going to get right into the next stuff. Right into it. So the thing we did last time was we talked about if I'm given this crazy polynomial function, something that I could not normally factor, right? Not with all the methods we learned before, some stuff we learned in here. I need to create a list of things that could work and then try to use each one of them, right? So that's what we did yesterday. So, for example, real quick, if I had this, could you come up with the list of all the possible rational roots of this? Does that phrase even make sense? Just this, the list of all possible rational roots. What does rational mean again? Not like in psychology terms, like is somebody rational, but in mathematical terms, what does rational mean? What's the root word of rational? And you're like, don't bring English into math. Ratio, right? So what is a rational number? It's just a ratio of two whole numbers with the bottom, or two integers with the bottoms not zero. So this is a list of all fractional answers, all the things that could be answers, right? So this list will not include like square root of 2, thank God. I'm not going to know if that's going to be an answer. That would come out from where? Where would the radical answers come from? If I was factoring something and finding all the zeros, where would the radical answers come from?
Unfactorable parabola, I don't know how to...
Quadratic, I love it. Unfactorable parabolic stuff. So quadratic, right? So it would come from quadratic formula. It's got the big old square root in it. So those answers, I have no idea how to predict those. They just happen, right? What would how do I create this list of all the things I'm going to have to try to use synthetic division with? How do I create that list? You guys here yesterday? I think you guys were yesterday.
You do all factors of the last term over all factors of the first term?
Yeah, so all factors of this guy, right? What are all the factors of 4? I'll start. 1, 2, 4 over all factors of this guy. Now, we talked about why that makes sense. We talked about why that makes sense. We looked at specific examples. We did that, right? So we know why this makes sense. Will all of these be answers? No. Could some of them be answers? Yes. And that's what we do. We make a list and then we try them out. And we kind of silently hope that we get lucky and pick one. Now, thankfully, there are 2 things that will help us decrease the list, right? So first off, what is this list? So I'm going to divide each of these by 1. Right? And then I'm going to divide each of these by 5. Okay, maybe. Right, so that's the list, and so you'd have to take each one. Now you could try to use 2 things. What's one thing? The dude that we named the XY plane after. What's that rule?
Cartesian rule.
Okay, sort of. The Descartes rule, right? You don't have to remember his name. You just have to remember what it means. That's the one where you look how many sign changes and so forth, right? What's the other thing that we could use as we're synthetically dividing? Say again? The bounds, right? Okay, maybe. Okay, so like if I divide synthetically and all the answers are positive, if I divide by a positive number, all the answers are positive, nothing will work that's above that number. So we did a few examples yesterday of that. If I divide by a negative number and all the answers come out alternating signs, then there's nothing below that negative number that would work. So I can kind of decrease the size of my list. So what did we decide yesterday makes sense? What would be a good thing to try first, maybe? One, yeah, I would agree with that. One's kind of like in the middle, right? These are all less than 1, and 2 and 4 are bigger than 1. One's kind of in the middle, so it's a good idea to kind of try something sort of in the middle first. Okay, I like it. Now, considering that I just made this completely up out of nowhere, I'll bet you that none of those work. I'll bet you that this is just gross. I'll bet you. If we wanted to try one out, what would I have to write here? Be careful.
5, 0,
Yeah, there's 5x to the 4th, no x cubes, negative 6x squares, 2 x's, and a negative 4, right? And then, of course, we should all know the synthetic division stuff. So let's see if we pull the 5 down, 5, 5, 5, negative 1, negative 1, 1, 1, negative 3. Is this some kind of a bound? Is this an upper bound? Could this be a lower bound? How do I know, right, before I even do the synthetic division, how do I know this can't be a lower bound? Say again? I think I hear that. Say again?
We have 2 negatives?
No. Even before I do this, I'm dividing by a positive number. It can't be a lower bound. So if I divide by a negative number and the answer alternates signs, that's a lower bound. If I divide by a positive number and the answer is all positive, that's an upper bound. So this is neither, right? Can somebody tell me, what does this tell me? I'll accept a couple of things. What does that negative 3 tell me? Did it go in evenly? No. Okay, it tells me that directly. What else did we learn yesterday that tells me about this? What is f of 1? Yeah. What is f of 1? Negative 3. Yeah. Remember we learned that the remainder theorem, right? We saw why that made sense. Okay, maybe. So all these things we do, you need to remember them. I'm going to test you on those. Okay. All right, so that's what we did yesterday. All of that. Okay. So you got to get into that section and try that homework out so you can see if it all kind of comes together and makes sense. And again, I forgot to look to see, I don't think the book talks about bounds. I could be wrong. I always forget to check. But it almost doesn't matter because we know about bounds, so we can use them. I don't think it does. No. Okay. Okay. See. No, I don't see it. Okay. No. All right. So that's stuff we did yesterday. Okay. So today, we're going to kind of do the next level. So we've been looking at polynomial functions, just polynomials. We've been looking at like finding their intercepts. We see if they turn or if they go through, all that kind of stuff. And how do I find the intercepts? I have to factor the damn thing, right? And what do we have now that we can use to factor something? Synthetic division. Okay, maybe. So just a quick example. Pull one out of here so I know it's, that's too easy. Yeah, that's freaky looking. Yeah. So let's say I have this function here. Take a minute and make a list of all the possible rational zeros. It's not going to be many, thankfully. guys get for the possible rational zeros? Spell zeros different ways. So what do you put on top? 1, that kicks ass, right? There's only plus or minus 1 for 1. What goes in the bottom?
1, 2, 4.
1, 2, 4. So then I can put this together. 1 over 1, 1 over 2, 1 over 4. So not a very big list, but 2/3 of the list are fractions, so oh well. So what do you kind of, well, let's see. What do you guys want to choose to try to divide this by? Let's do like we did yesterday. Everybody pick a different, how many numbers are there to pick from? 6. So everybody pick one. Let's see if, don't everybody pick 1, right? But everybody pick one of those numbers and try it. What do you have to be careful about when you set up the synthetic division? What's missing? X squared's missing, so be careful. Okay. So I'm going to pick one. I'm going to pick this one. This is crazy. Oh, gross. Oh, shit. See, 8. I know this is not going to work. Negative 11. So it'll be negative 11/16, and that's not going to be 0, so screw it. It's not going to work. So 1/4 doesn't look like it works. Okay. Anybody else have better luck? Anybody get one that works? 1? Okay. 4, 4, 4, 4, 1, 1, 0. Sweet. Everybody get a different thing that works? Say again? Negative 1/2? Let's see. Remember this, you can just kind of keep going. So bring the 4 down, times negative 1/2 is negative 2. Add, multiply, add. Sweet. So then what do we have? What's this represent? X minus 1. What does this represent? Good, x plus 1/2. And of course, what is this? 4x plus 2. Now, we don't really like to have the fractions in there if we don't need to, right? Do you notice how this has an extra factor of 2? You guys see that? So I can take a factor of 2 out of here and put it in there. This becomes so what do you notice about that? What are all the zeros? Does everybody see what just happened? I took a 2 out of here and I put it in there. So I took a 2 out, that's 2x plus 1, and I multiply that 2 through there, bam. What do you notice about this? Now, what are the zeros? What are the zeros? 1? Negative 1/2? And negative 1/2, so you get one that repeats. So this would be x minus 1 times 2x plus 1 squared. So what would it do at negative 1/2? At the x-intercept negative 1/2, what would it do there? Turn. I love it. So I want you to realize what this last section did is it adds some extra work on. This previous section would start us here, yes? Or give us something that was easy to factor so we could get here pretty easily. This new section says, all right, we're going to start you way the hell back here. And you got to use synthetic to get here, and then you do all the same stuff we did before. Find the x-intercepts, find the y-intercept, plot them, figure out where it turns and goes through. You guys with me? All the same steps we did on the test. Okay. Maybe. Okay. All right. All right. Okay. So that's what we did yesterday. So let's do some new stuff. Oh, poor little dude. Oh. So you guys can see that. Okay. I don't know if you noticed my shirt. Went for breakfast this morning. Everybody's like, oh, you must be a math teacher. I'm like, what gave it away? So this is my favorite little thing. I don't know if you guys understand. What's the idea of my shirt?
The dotted line is the asymptote of 1 over x.
I love it. So there's an asymptote, right? This asymptote where I have to approach it. There's this really silly math joke about asymptotic high five. Just never get there, right? This one's real, also said, but I love it. You shall not pass. So I have to. Okay, maybe. I don't know if this is familiar to anybody. You all know the word asymptote. Is this true? Sounds like I'm going to say something terrible, and then I turn it around. Okay. So what if I had, let's take a look at a very simple function. Can anyone tell me the domain of this? And the way you answer the domain question is you normally think either what has to happen or what cannot happen. So in this case, what value of x makes this freak out?
0. Or no?
0 is fine. Makes it 1/2.
-2.
Yes. So don't say 0. Think what makes the bottom 0, right? Bottom can't be 0. What makes the bottom 0? -2. So the domain would be x not equal to -2 or -infinity to -2. So you kind of skip -2. That's old stuff. We've done that before. Which means when I go to graph this, what is the most interesting point to figure out what it does? -2. So it's not allowed to use -2. So what the hell is the graph doing as the x's get close to -2? Think about that for a minute. I'm not allowed to use -2, correct? I can't put a -2 in. So then the next best thing I could do is get really close to it, right? So I always think about, I like to watch horror movies a lot. There's an old horror movie from the 80s called the Blob. Of course, it's from the 50s before that, but has anyone ever seen the Blob, the movie? So this thing crash lands on Earth, and this guy's coming up, and he's like, oh no, what's that? So he's like, I don't know what that is. Let me get close to it. And the mistake he makes is he touches it, right? So he tried to put 2 into his function, -2 in there, and he freaked in and eats them, and it's terrible. All right, sorry. If you don't like horror movies, it's fine. Most everybody else survived. Anyway, so I want to get really close to -2, but can I actually get there? No, I can't get to -2. So I want to let my x's approach -2. So as x approaches -2, I'm very curious, what do the outputs do when I get really close to -2? Now, can somebody help me out? Can somebody give me a number really close to -2? Yes?
-1.99.
Holy shit, right? -1.99. That's pretty close to -2, yes? Can somebody else give me a number on the other side of -2? That's really close to -2. Do you understand what I mean? -1.99 is on this side of -2, yes? What's on this side? Somebody else? -2 point. I can almost hear you. -2.1. I love it. Kick ass. Okay, so what I want to do is I want to approach -2 from the left. So here's -2, and I want to approach it from the left. So that's what this means. So I'm going to make a little XY table. You guys are going to help me out. So like here's -2.5. right? Negative 2.5. So let's put that in there first. Somebody put negative 2.5 in there. Let me know what that is. Can you guys do that?
2.
Say again?
2.
No? Close. So it'll be 1 divided by, parentheses, negative 2.5 plus 2. Say again? Say again? Say again. Whoever said that, you got it right, but say it again. Negative 2, right? So, what's negative 2.5 plus 2? Isn't that negative 0.5? Right? And then 1 divided by a half is 2, but there's a negative. So that's negative 2. Again, everybody verify that's true. Do it in your calculator. Now let's go negative 2.1. Let's get closer. So we see the blob down there, and we're like, what is that? And we're like, what the hell is that? You know, we're not going to freaking touch the thing. We're just going to get close, and then probably back the hell away. Right? So when you put a negative 2.1 in there, see? Negative 10, because 0.1 is 1/10. 1 divided by 1/10 is 10. So that's negative 10. So you can kind of see the idea already. What if I put in there negative 2.01? I really want you guys to understand why we're doing this. I'm not allowed to put negative 2. So the next best thing I can do is plug stuff in close to negative 2. Because the only number that I'm not allowed to use is negative 2. But I can use every other number. So I can use numbers that are really close to negative 2, just to kind of see, what is this thing doing? So when I put in negative 2.01, I got 1 over negative 0.01. 0.01 is what fraction, 0.01? What's 0.01 as a fraction? 1/100th. So 1 divided by 1/100th is 100. And there's a negative. So what's it look like the outputs are doing? Getting way bigger, right? Well, negative, getting really big negative. Can you imagine if I put negative 2.0000001? You guys with me? This will be 1, 0, 0, 0, 0, 0, 0. So here's what's happening graphically at negative 2. So at negative 2.5, it was negative 2. At negative 2.1, it was negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, good job, John. And negative 2.01 is negative 100, so this thing is just kind of like, wah. Again, can I ever put negative 2 in? Am I allowed to put negative 2 in? No, because it makes it go crazy, right? So there's an asymptote right here. There's a wall right here. Because I'm not allowed to put it in. So there's a wall right there. And there's a little Gandalf there. Every time you draw that wall, a little Gandalf appears. He's like, what the shit? You will not pass. And I also am, I'm obviously a remarkably big geek. I teach math. So I also think about Star Wars. The shield generators will pull up. It's still operational. Okay, anyway. So from the other side, it's probably going to do this. Let's find out. How do I investigate this side? What kind of numbers am I going to want to plug in to investigate this side of negative 2? Negative 1, negative 1.5. I'm going to want to get really close to negative 2 from that direction. So I want to look as x approaches negative 2 from the right. So does everybody get this, what this notation means? Here we allowed x to get close to negative 2 from the left. So it's getting closer and closer to negative 2. Here, so let's start with negative 1.5, and then negative 1.9, negative 1.99. Let's see what happens. So if I plug a negative 1.5 in, 1 over negative 1.5 plus 2 is 1 over 0.5. 1 divided by a half is positive 2. Do you guys see that I'm going to get something very familiar? Just positives now. Are you guys cool with this? You guys see this? Negative 1.5 plus 2 is positive 0.5. So 1 divided by a half is 2. When I put in negative 1.9, I get 1 divided by positive 0.1. So I get positive 10. So of course here, I'm going to 1 over 0.01, so I get positive 100. So now it's just getting really big, positive. So as I approach 2, so negative 1 came out to be, negative 1.5 came out to be 2. Negative 1.9 came out to be 3, 4, 5, 6, 7, 8, 9, 10 came out to be 10. So this thing, as it approaches, is just going to go crazy and go straight up, almost. Pretty much looking like my shirt. Now notice I haven't done anything this way yet. We still have to talk about what happens as I get away from negative 2. So what kind of line is this dotted line? This is a vertical line, right? And why is it right where it is? Because what's the x value I can't go through? What's the x value I can't use? Negative 2. So I put a wall at negative 2. Does that make sense? I'm not allowed to use it, so I put a freaking wall there. So if my function is coming at it, it's going to pull up. Oh shit, right? It's going to have to, I can't hit the wall. Maybe. All right. So let's talk about what happens as x gets really big. Positive or negative. Okay. So let's do that. By the way, is there an X intercept to this? What's the only way a fraction can equal 0? What's the only way a fraction can equal 0? If the top is 0. What is the top of that fraction always? 1. So can there be an X intercept? No. There's no way to make that 0 because the top is always 1. What about Y intercept? How do you get the Y intercept? Make x equal 0. What do you get when you make x 0? 1/2. Okay, so the Y intercept is 1/2. That's cool. Okay. So now I'm really curious. What's it going to... I know what it does right around negative 2. It does this weird thing on both sides, right? It does this weird thing. But now I'm curious, what if x gets really big? So now I'm curious what happens when x goes to positive infinity. What happens if I let x get really big? What does this function do? All right, so we can see this very quickly. So can somebody tell me, what are some good numbers to plug in? I want x to get really big. So give me a good first number to plug in. I want x to get really big. Say again? 50? Sure, what the shit? 50. So then I get 1 over 52, correct? Which is about 0.019 something or other. You guys can check me. That's a guess. So what about 1,000? 1 over 1,002. Is that cool if I put 1,000 in there? And that is about 0.001, roughly. It's probably 0.0009 something or other, right? And again, you guys can check me. It's really early. You never know. What seems to be happening the bigger my input gets? What is my function doing? What are the outputs doing? What are my outputs doing?
Getting as close to 0.
Getting very small, right? So what's going to happen to the function as my inputs get bigger? It's going to go to 0. There's going to be an asymptote right there. As I increase x, I'm dividing 1 by more and more and more. So my outputs are getting smaller and smaller and smaller. And the same thing's going to happen if I let x go to negative infinity. So if I put in negative 50, that's going to be 1 over negative 48, which is like negative 0.02 something, I think. Again, you can check me. If I put in negative 1,000, I'm going to get 1 over negative 998, which is about negative 0.0011 maybe, something like that. Again, check me if you want to, or just accept it. So what's happening back here, it's getting really small, but they're always negative outputs, right? But they're getting really small, yes? So back here, the outputs are negative, but they're getting really small. So again, it's approaching 0. So it looks just like that. Maybe. So how many walls did we end up with in this picture? 2. I like it. One of them, the vertical one, this is a vertical asymptote. This one here, right? This guy. It came from the domain. It came from what can x not be. X can't be negative 2, so I have to put a wall at x equal negative 2. And this one came from what happens when x gets really big. Does the function start to approach something? Okay, maybe. Okay. So thankfully, we're not going to have to make these tables forever. We can kind of generalize some stuff we just discovered. So let's try another problem out real quick. Let's see. Oh, turn this guy off. Go ahead. Whoa. Hey, old stuff. So let's say I've got this here. Sure, I like it. Let's do some really basic stuff. There's certain things you can do no matter what the function looks like. So one thing you can always do no matter what the function looks like is find the intercepts. Let's get the y-intercept first. So intercepts. So what's the y-intercept? How do you find the y-intercept always? Make x 0. So what do you get when you make x 0? Negative 2. So the y-intercept is 0, negative 2. Now again, remind me, in order for a fraction to equal 0, in order for the output of a fractional thing to be 0, what has to be true? To make a fraction 0, what has to be true? The top has to be 0. So for the x-intercept, what makes the top 0? Negative 2. Well, that's kind of nifty. Let me stop for a minute. So do you notice? I don't care what the function looks like. How do I always find the y-intercept? Make x 0. How do I always find the x-intercept? Make y 0. That kicks so much ass. No matter what function we're looking at, I can do the same thing for the intercepts. Can somebody see, just by looking at this thing, what the vertical asymptote is?
1.
X equals 1, I love it. So there's going to be a wall at x equal to 1, because that's the value I can't use. What about horizontal asymptote? This is going to be a little bit trickier. So we're going to have to think about it for a minute. Okay, in fact, I'm going to kind of do this problem on the side here. So this is a little new. This problem is new from the last problem, because this problem has x on the top also, correct? Okay. So watch what we can do. So we're going to do a lot of kind of proofs of ideas, and then we're going to sort of generalize the ideas. So I don't have to do the proof every time. But let's just look at this. Let's look at the horizontal asymptote. So I want to let x get really big positive and really big negative to figure out the horizontal asymptote. What is it going to eventually have to do in both directions? Right? That's the question. So if I look at this, okay, this is where things get interesting. Now, real quick, the one we just had a minute ago was this one right here, right? We had this one before. Do you notice what happens when the bottom gets really big? The top is just always 1, right? So when the bottom gets really big, the whole thing goes to 1 divided by big, which is small, which is 0. Do you notice here, as x gets really big, both the top and the bottom are getting really big. Does that make sense? So over here, the bottom kind of overwhelms the top when I let x get really big. Does that make sense? If I let x get really big, the top is going to get overwhelmed because it's just always 1. 1 divided by 10, 1 divided by 100, 1 divided by 1,000, 1 divided, what the shit? So it's just going to go to nothing. It can't keep up. Here, these are both kind of growing at the same pace. So let's try this. Okay, let's look at this. So if I put a 10 in there, what do I get? 12 over 9, right? Which is 1.33333. I think, yes. Okay. What if I put 100 in there? 102 over 99. What's 102 divided by 99? It's 1 point something. 1.03, something like that. Anybody gonna help me out? What is it? Is it 1.03 roughly? Okay. So it's roughly 1.03, right? What if I put 1,000 in there? I get 1,002 over 999, and that's going to be like 1.000. You guys can help me out. I don't know how many zeros. Maybe 2 zeros? 2 zeros and then a 1? Okay. So what does it look like is happening as my inputs keep getting bigger? What do my outputs look like they're doing? They're going to, what do you guys think? What's happening to my outputs as my inputs get bigger? They're getting closer and closer to 1. You guys see that? So I really want this to make sense. Why? How quickly? What is it that tells you how quickly something's growing? Isn't it the slope? If I want to make a line grow quicker, I have to make its slope bigger. Yes? Don't both of these have the same slope? Right? They both have the same slope, meaning they both grow equally quickly. So that means when I divide them, I should expect to get closer and closer to 1 as the x gets bigger and bigger. They're both growing at the same rate. So here's a shortcut. Here's one shortcut for this. We've already developed a couple things. So notice something. For horizontal asymptotes, if the bottom degree, what's the degree of the bottom here? What's this degree? It's the first degree, yes? If the bottom degree is bigger than the top, if the bottom degree is bigger than the top, doesn't that mean the bottom is growing faster? Right? If I'm dividing by bigger, 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 isn't my output getting smaller, smaller, smaller? So that would mean that that asymptote would be 0. The same thing we got for this when we graphed this over there. We got an asymptote at y equals 0. So if the bottom degree is bigger than the top, the horizontal asymptote is y equals 0. And if the degrees are the same, because here, what's the degree at the top? First degree. What's the degree at the bottom? First. So they're the same. If the degrees are the same, then the horizontal asymptote equals the ratio of the leading coefficients, 1 to 1 in this case. The ratio of the leading coefficients. Oh my God, Jeff, let's see. This is really tough. Sorry. Ratio of the leading coefficients. So in this case, it was 1 to 1. So here, the horizontal asymptote is going to be y equals 1. We'll see some more examples, don't worry. And I've got this kind of like on this handout. I've got the rules kind of summarized for you. All right, so let's see if we can keep going here. Too many layers of whiteboard. Okay. So I've got my intercepts, I've got my walls, where to put my walls. So if I start to graph this thing, let's see, I've got asymptotes, so let's see, I've got intercepts, 1, 2, 3, let's see, 1, 2, 3, I've got an intercept at 0, -2, and -2, 0. I still have to figure out what my scale is going to be. I don't know yet, so I'm going to leave the y-axis blank for a moment. So my x-intercept is -2, 0. Where's my vertical asymptote? Looks like it's going to be x equal to 1, so I can put a wall right there. Now I want you to notice, let's go ahead and do this. I think it's going to be safe on this one. We'll have to be careful here eventually, but let's go ahead and make a scale like this. 1, 2, 3. I think we'll be fine. Normally you have to be careful about your scale. This one's simple enough. I think we'll be okay. So let's go ahead and make the y-axis scale by 1s. Let's see if I get in any trouble. So now I can put a wall. Is this cool? I got a wall at x equal to 1. And then I have one at y equal to 1. So right here. So see if this makes sense to you guys. Where's my only x-intercept? It's down here, right? You guys with me? So that means, see over here, oh, my y-intercept, I can put that on there now. Y-intercept is 0, -2. There we go. Right. Do you guys see what it looks like over here? So the vertical asymptote breaks it up into little regions. There's this region here and this region here. If I only look at the walls, my graph could either be here or it could be here. Obviously, which one is it? It could either be here or it could be here. And considering where I've got points, is it on the top or is it on the bottom? It's on the bottom. So you can see it. It looks like it's gotta approach this, and then it's gotta approach this. So once I draw my walls in, it's kind of nice because I know where my function has to be. I just, if I get a few points, I know exactly where it is. Now over here, what's a good function value to figure out? What's a good number to plug into the function to make a point? I want to investigate over here. So what's a good input to plug in? Sort of like we did with polynomial functions, then we have to do like f of 2 and f of negative 1 to see how tall it was, right? So what's a good function value to figure out? Maybe at 2, right? So what is f of 2? What would f of 2 be? Yeah, 4 over 1, so it's 4. So f of 2 is 4, so it's up here. Now, now again, all this is brand new to you, so just kind of absorb, right? I really want you guys to start seeing, once I got the walls down, I know there's only certain things you could do. So with these walls, it could either be up here, or it could be down here. Before I did that point, I knew it couldn't be down here. If it was down here, what does it have to go through eventually? Doesn't it have to go through the x-axis? If it went through the x-axis, would we not have found another x-intercept? There's no way it could be down here unless it goes through the x-axis. And do we find more x-intercepts? No. So I already knew it wasn't down here. But now that I did that point, I really know it's not down here. So it goes like this. I'm going to make this a little extreme. And then like that. Make this point big. Everything's fine. So it goes like this. Crazy shit. Maybe. So you got your old standbys, your intercepts. You can find your intercepts, right? Then you got some new stuff. The walls, the vertical and horizontal asymptotes, right? Okay. And then you got the old stuff. Find any function value you need so you can tell where something is. Okay, let's try a funky problem, and then I'm going to hand out this thing and let you guys try a problem on your own. Let's see. Yeah, let's do 2 minus 3 over x squared minus 5x. Let's say, yeah. Yeah, let's do that. All right, let's try to just attack this thing, right? The old stuff. So no matter what function I give you, you can always just find the intercepts. That never changes. Or whatever, no. How do I find the x-intercepts? So again, in a fraction, the only way to make it 0 is if the top is 0. So to find the x-intercept for any rational function, you just say, what makes the top 0? So what makes 2x minus 3 0? Yeah, add the 3, divide by 2, so 3 halves. There's an x-intercept at 1 1/2. You guys cool with that? The only way a fraction could be 0 is if the top is 0, and 3 halves makes the top 0. So that's the x-intercept. What about y-intercept? Y-intercept kicks so much ass. How do I find the y-intercept? What do I always do to get the y-intercept? Make x equal to 0. So of course, if you make x equal to 0, what do you get? The negatives cancel.
1/2.
You get 1/2. Okay. All right, so there's your intercepts. Let's see, vertical asymptotes. So vertical asymptotes always come from, what am I not allowed to use? They come from the domain. What's kind of sucky about this one compared to the ones we did earlier? So that was nice and easy, that was nice and easy, right? I can just tell x equals 1 makes him die, x equals -2 makes him die. Easy. What's a little bit worse about the one I gave you here? Can you just tell what makes the bottom 0? No. What do you have to do to the bottom to see what makes it 0? Factor. Cool. Take a second and factor that bottom. Be really careful. It's not 2 and 3. I'll tell you that. So anybody got that? How do you factor that? Yeah, -6 plus 1. Cool. So what are the vertical asymptotes? Again, vertical asymptote really just means x equals what that would make it undefined, right? So what are the vertical asymptotes? 6 and -1. You can't. So at x equals 6, there's going to be a wall, and at x equals -1, there's going to be a wall. So now we got 2 freaking walls, up and down. Okay, maybe. Again, why does that make sense? I have to put a wall there because I'm not allowed to go there. So I'm going to kind of slam up against that wall somehow. What about horizontal asymptote? What situation am I in? What's the degree of the top? First degree. What's the degree of the bottom? Second degree. So who's growing faster? The bottom is. So if the bottom gets way big and the top can't keep up, the whole thing is going to get really small, right? Something divided by bigger, bigger, bigger gets smaller, smaller, smaller. So anytime the top degree is smaller than the bottom, the horizontal asymptote is 0. It's going to have to go to 0. It's going to have to kind of die over time, poor little dude. I'm dividing by more and more and more. So if the top was squared, was the second degree, and the bottom is the third degree, y equals 0 is the horizontal asymptote. Okay. So let's kind of put this all together here. So I've got 6. Put a wall at 6. And I've got -1. Put a wall at -1. My x-intercept, I've only got one x-intercept, and it's at 3/2. Okay, so now I've got to be careful about what I want to make my y scale. Right? So, for example, can you guys, how many regions did I just break this up into? I broke it up into 3 regions. 1, 2, 3. So in each region, I have to figure out where is this function going to be. So I can do my horizontal asymptote right now. It's right here. So for example, in the middle, does it do this? Or does it do this? Or does it do this? Do you guys? So in the middle, I know it goes right to the x-axis here, right? So either it kind of goes like that, or it goes like that, or it goes like that. Because what does it have to do when it gets to this point? What does it have to do? It has to run up against it. I just don't know if it's coming from down here, if it looks like a parabola. I don't know yet. So can somebody tell me a good input to use for that middle region? Well, we know the y-intercept, don't we? 0, 1/2, right? So I know it's going to be up here. So a really good point to plug in would be something over here. So for example, what do you get when I put a 3 in there? What do I get when I put a 3 in here? I get 6 minus 3 is 3. And 9 minus 15 is negative 6 minus 6 is negative 12. I get negative 1/4. Okay, so I know at 3 it's down here. Maybe. What about over here? Do you guys see the walls? There's a wall here and there's a wall here, right? So can you see that it either is this or it's that? Do you see that there's the only two things you could do? It could either do this or it could do this. I just have to figure out one function value and I know which side it's on. What's a really good input? 7. So what's f of 7? 14 minus 3 is 11 over 1 times 8, 11/8. So now I know at 7 it's up here, so it's going to be like this. Notice I haven't plotted those points yet. Notice I haven't figured out my y scale yet, right? What about back here? It could either be like this, right? Because it's got to go up against that wall, it's got to go up against that wall, or it could be like this. So again, what's a good input to check out? Negative 2. So what's f of negative 2? That would be, let's see, negative 4 minus 3 is negative 7 over negative 8 times negative 1 is 8. So negative 7/8, it's down here. Okay. What are all my outputs I've got so far? I've got a y-intercept at 1/2. I've got a value at negative 1/4, 11/8, negative 7/8. Do you guys see that? Do I have any big outputs that I have to graph? No. So I want my scale to be kind of small. In fact, maybe I'm going to make my scale like this. 1/2, 1, 3/2, 2. Negative 1/2, negative 1, negative 3/2, negative 2. I mean, it's totally up to you as long as the scale is consistent. So if I have some small freaking outputs, I'm going to kind of like blow my scale up, kind of zoom really in on it, right? I'm not going to make it 2, 4, 6. I'm going to make it 1/2, 1. So let's plot some stuff here. Let's see. So we got my x-intercept here. Now I can plot my y-intercept right there. By the way, that's just 1/2, right? F of 7. So real quick, I'm sorry. Let's do f of 3 is negative 1/4, so that's right there. So do you see how here it's doing this? Here it's doing this. Do you guys see that? How do I know it's not doing this? How do I know it's not doing this? Yeah, because if I needed to get back up, I'd have to go through the x-axis again, but I only have one x-intercept. I consider this to be like a door. That's the only place you can go from one side to the other. So I know it's here, and I know it's there, and I know it's there. So it's got to go like this. It kind of looks cubish, right? What about over here? So f of 7 is 11/8. 11/8 is like 1 3/8. 1 1/2 is here, so 1 3/8. So it's about right there, maybe. So then it's got to slam up against this wall here, and it's got to slam against that wall there. So when you make your walls, it's really kind of nice. Because when you make your walls, you know where the function has to kind of live. There's only certain options. And once you figure out an output, you can pretty much fill it in. So over here, f of negative 2 is negative 7/8. It's almost -1. So right there. So then back here, it's got to be slamming up against that wall, slamming up against that wall. So the walls are, that's one reason why you start with the intercepts and then the walls. Because together, those tell you a lot. Those tell you where your function could be. And what's the ultimate way to check this? Put it on a graph counter, yeah. And then you can double check it. Okay, maybe. So let's see. Let's put it into Desmos, because that's easier for me to get a hold of. Wake up. Oh, it's already there. Let's see, what was this again? There it is, 2x minus 3 divided by x squared minus 5x minus 6. There it is. Isn't that basically what we've gotten? I see there. In fact, let me put in here and make this a little more specific. Y equals, let me put in here. X equals, what was it, 6? And x equals -1. So there's your walls, there's our asymptotes, just like we have. Is that cool? Can you guys see that? So it's kind of nice, you can very quickly check your work. Just be really, really careful. Some of you guys didn't really heed my warning. If your graph is way too nice, especially if your graph does not match your work, oh shit, you're going to lose a lot of points. So don't just copy from a calculator. Okay. But it's not a bad idea to check your work. Kind of makes sense. So let me give you guys this here. Or actually, you already have this. You guys have this still? Tell me if you don't have this. Let me turn this bad boy on here. This is the one I gave out yesterday. It's got Descartes stuff we did. So we did this side. Oh shit, now. You are strange. Get over there. There we go. We did this side yesterday, right? So does anybody need this? Oh, that's right. Okay, you guys for sure need this. So I highly recommend, if you weren't here yesterday, you go watch that, the video, the lecture. There's a lot of shit we did yesterday. So now on the other side is this. So I want to point this out first. So look at the first two. These are the two we already talked about. If n, so notice, okay, right here is the most general example of a rational function, right? If n is 2 and m is 3, that would be a second degree over a third degree. Are you guys with me? So n and m are the degrees. So x to the n is the highest degree on the top. What's a sub n mean? It's a number. So that could be 7x squared. If n was 7 and n was 2, that would be 7x squared. On the bottom, b sub m is a number, like 3, and m could be 3, so that would be 3x cubed, right, for example. Are you guys with me? So just got to capture all the possible things you could be. So if the top degree is smaller than the bottom, or the bottom is bigger than the top, either way, that means the bottom overwhelms the top. It goes to 0. I'm dividing by bigger, 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 so the whole thing goes to 0. So that's a horizontal asymptote on the x-axis, at y equals 0. If the degrees equal each other, then the horizontal asymptote is the ratio of the coefficients of the highest degree terms. So it's just the ratio of the numbers in front of the highest degree terms. The one we didn't talk about yet is if the top degree is bigger than the bottom, there is no horizontal asymptote. It's going to go to infinity. If the top is growing faster than the bottom, it's going to get bigger, bigger, bigger. Now, it creates something called the slant asymptote, which we will talk about later, not quite yet. So that's why I haven't done this one yet. Okay. So, this guy. I'm going to kind of let you get a little ahead of me, and then I'll catch up. So first, I just want you to find the intercepts for that guy. Do that first. So the y-intercept is always really straightforward, or almost always, right? So how do you find the y-intercept? You just have to make x 0. So if I make all the x's 0, what do I have left over for the y? 1 1/2. Okay. Now, why is the x intercepts on this problem a little harder than the ones we've done so far? What do I look at to get the x intercepts? I look at what makes the top 0, yes? What are the x intercepts supposed to do? They're supposed to make the function 0. What's the only way a fraction can be 0 is if the top is 0. So to figure out the x intercepts, I have to figure out when 3x squared minus 3 is 0. What makes the top 0, right? Now, how do you solve this? Yeah, factor 3 out. And then what can I do with this? X plus 1, x minus 1. So what are my two x intercepts?
1, 0.
All right. So it's negative 1, 0 and 1, 0, right? Is that cool? Okay, maybe. By the way, what's the multiplicity of each of those? What's the multiplicity? What's the power here? And there. So these are both odd multiplicity. They're both multiplicity 1. So what are they going to do at those roots? They're going to go through. So that still is true. That's still a true thing. You can still do that. All right, so now we know all the intercepts. Take a minute to figure out the vertical asymptotes. Oh, that's right. So how do you figure out what values of x are not allowed? What do you have to kind of solve? Or what do you have to do to see those? Yeah, the only inputs that are not allowed are any inputs that make the bottom 0. So you can sort of just look at this problem here. So the vertical asymptotes are the values that make that 0, because then the function will freak the shit out, right? So how do you factor that? Yeah. So what are my two vertical asymptotes? 2 and -3 and 2. So I have walls there. I like it. Okay. So far it's not too bad, right? So the vertical asymptotes are walls because they're telling me you can't go here. All right, well, what is it about a function that would tell me there are certain inputs I can't use? The domain of the function. So for a fraction, the bottom can't be 0. Okay, so if I can find what values make the bottom 0, that's where I put my vertical walls, because then I'm telling myself I can't go there. Okay. Now, I want to do a little deeper dive into this. What situation are we in? Which of these 3 situations are we in? The degree of the top and the bottom are the same. And what's the leading coefficient of the top? And what's the leading coefficient of the bottom? 1. So I would expect y = 3 to be my asymptote, my horizontal asymptote. But I want to do a little bit deeper dive on that. Of course I do. So if I think when x gets really big, positive infinity or really big negative, right? I'm letting x get really big. That's the whole idea of horizontal asymptotes is as my inputs get bigger and bigger and bigger, what are my outputs doing? Are they approaching something? Are they going to infinity? What are they doing? So tell me this. Does that make sense? So I'm letting x get really big. So when I'm thinking about horizontal asymptotes, do I care about x = 0? What am I letting x do to consider horizontal asymptotes? I'm letting x get really big. So do I care about x = 0? Nope. I just want x to be really big, correct? And I love you guys. You're all like, what does this question mean? What are you doing? Okay. So look what I can do with this thing. What's the highest degree term in this whole thing? Second degree. So let me just rewrite it here so I get some more room. I'm going to divide the top and bottom by that highest degree. So then if I do that, 3x squared divided by x squared is 3. 3 divided by x squared is 3 over x squared. X squared divided by x squared is 1. X divided by x squared is 1 over x. And -6 divided by x squared is -6 divided by x squared. So I divided top and bottom by the same thing, yes? Totally allowed to do that. And what was that thing? The highest degree term I saw. Now look here. What happens to this when x gets really big? 3 divided by really big, right? What does that go to? If I let x get crazy big, 3x squared is going to get really, really small. It's going to go to 0, yes? So that goes to 0. This goes to 0. And don't these two do the same thing? Now 3 is just 3. It don't give a shit what x is doing. It's just 3. So if I do this, let x get really big here, what do I end up with? What's the only stuff left alive? 3 over 1, which is 3. That is a semi-proof of when the degrees are the same, the asymptote, the horizontal asymptote is y = the ratio of the leading coefficients, because they are the only things that would be left alive if I did this. Okay. Maybe. All right, so go ahead and try. So there's my wall, my horizontal wall. There's my vertical walls, and there's my intercepts. Go ahead and try to figure out those values, and then see if you can graph it. Put all that stuff together. That's what I get. So let's see, we got X intercepts at 1, 0, negative 1, 0. We've got, let's see what else we got. We have walls at x equal 2 and x equal negative 3. Cool. So I kind of have a lot of information in here. I'm going to also have a y-intercept I can plot once I figure out the y-axis scale, right? So you can see why, do you see why I had you do f of negative 4 and f of 3? Because can you guys see the regions this broken up into? So I haven't done my horizontal asymptote yet. I haven't done my y-intercept yet. I haven't done anything of the y because I don't know what the scale is yet. But can you guys see already there's a region here, there's a region here, there's a region here. So that's why I had to do f of negative 4 and f of 3. So you can see what's happening in those regions. So what do you think my y scale should be considering these outputs here? What do you think my y scale should be? Is the scale by 1s good enough? I want to be able to plot 7.5, right, as an output. So maybe I should go by, you guys with me? I want to be able to plot up to 7.5 at least, so maybe up to 8. I want to be able to plot that far up. So I don't want to go by 1s because then the top would be 5, right? So what do I want to go by instead? 2s, maybe. Yeah, 2. So let's see. So I'm going to make this 2, 4, 6, 8, 10. Negative 2, negative 4, negative 6, negative 8. 10. This, of course, is 1, 2, 3, 4, negative 5. So now I got my scale. Now I can put my horizontal asymptote in there. Y equals 3. So that's right here. So I've got this horizontal asymptote there. really, really desperately want you guys. Do you see how up here, it could either be up here or it could be down there, right? Do you guys see that? It could either be here, hugging these walls up here, or it could be down here. How do I already know it's not down here? Yeah, f of 3, I know, but also, even before I did that, there's no X intercepts here, so there's no way it could do this. But also, f of 3 is 4, so I know it's up here. So I know it's got to do this. I can do, what point have I not plotted yet? There's one point I haven't plotted yet because I didn't know my y scale earlier. Y-intercept. And so that's 1/2. It's right there, right? Now, listen. What did we say the behavior was at each of the intercepts? Because the multiplicities, I don't remember if we said it here, but you see how the multiplicity, yeah, we did. The multiplicities are 1. So what's it going to do at each one? Go through. So could it start up here? If it went through, how is it going to do this, right? So can you guys see how it's got to do this? It's got to go through there. It's got to go hit the y-intercept, and then it's got to go through there. So it doesn't have to be like a cubish dude, right? It could be parabolic. And now, of course, I was really nice and told you to do f of -4. So that's 7.5, right? That's way up here. So do you see how before I did that, it could have been down here or it could be up here, and now I know it's up there. So that's what it looks like, and of course you could check it on the calculator, right? You can check it real quick if you wanted to. So there are a few moving parts to this. There are several things to kind of keep in check, but you put them together exactly like we did. I put my X intercepts down, and then I put my vertical asymptotes down. And then I figure out what function value, what other points am I going to need. Once I get those other points, I know what my scale is going to be. Right? What if f of 3 would have been 20? And I had a scale 1, 2, 3, 4, 5. I'm screwed. So I don't want to make my scale until I know where my points that I want to plot are going to be. Okay, maybe. Okay. Let's see. Okay. We brought one example. It's really good, Jeff. Well, we can make another one. Let's see. I think this is all right. Let's see. You guys just have to try these out. Real quick, let's do a couple of lightning sessions here. All I care about on these problems are the horizontal asymptotes, right? So what if I had this guy? All I care about on this problem is the horizontal asymptote. So, what are the shortcuts for the horizontal asymptote? I have to think about degrees, right? What situation am I in? What's the degree of the top? Third degree. What's the degree of the bottom? Third degree. Yes? So therefore, my horizontal asymptote is going to be the ratio of the leading coefficients, right? Who can see those? Yeah, -2 over -3, right? The leading coefficients are the numbers in front of the highest degree terms. Do you see how I just put them out of order? Because I'm evil, right? Math teacher, I'm automatically evil. But you just find the highest degree terms. So you know they're both third degree, so therefore the horizontal asymptote has to be the ratio of the leading coefficients. And those are -2 and -3, so it'll be 2/3, right? So I would have a line, horizontal line at y equal 2/3. Is that cool? What about, let me do it like this. Horizontal asymptote, that's all I care about. Don't say anything yet, don't say anything. Isn't this kind of a nice problem in a way? Could you tell me really quickly what the X intercepts are? So I guess I am more concerned than just horizontal. So let me ask you a few more questions. What are the X intercepts? Why can you see them so easily? What are they? Can you see them? 1 and -4. X intercepts are what make the fraction 0, and the only way a fraction can be 0 is if the top is 0. So when I say X intercept for a rational function, you just care about the frickin' top, right? So 1 and -4. What's it going to do at 1? Turn. It's a even multiplicity. So I know all this shit. We know this shit from before, right? What are the vertical asymptotes? Why are those easy to see? There's going to be x equals 0. There's going to be a wall at x equals 0. -2. And 3. There's going to be 3 walls. Vertical walls. Is that cool? Okay, now let's talk about the real thing. Horizontal asymptote. What situation are we in? What's the degree of the top? Third, beautiful. Everybody see that's a third degree. It's not second degree. It's the highest power that it would have. And the highest power it would have would be a third power, right? What about the bottom? Fourth degree. So the top degree is smaller than the bottom. So the bottom is more powerful. So what's the whole thing going to do? It's going to go to what?
0.
I'm dividing something by something that gets bigger, faster, so it's going to go to 0. Y equals 0. There's going to be a horizontal asymptote right on the x-axis. Kick-ass. Now let's do one. Okay, now let's investigate this freaking slant asymptote. So I'm kind of giving the game away a little bit here, but let's see. What do you got, Jeff? Yeah, let's do a simple one. Yeah, let's do a simple one. I like it. So let me ask you a couple of other questions. Anybody see the X intercepts? So, yeah, +1 and -1, right? Because if you factor the top, x plus 1, x minus 1, 1 and -1, right? Easy. Where would the vertical asymptote be? -2, because that's what makes the bottom 0, right? So that I got to put a wall there because I'm not allowed to go there. Is everybody doing all right? What situation am I in? The degree of which one is bigger? Top or bottom? Top. So the top is growing faster. So this is going to go to infinity. This is going to go to infinity. But it's going to get there in a very defined way. Oh shit, this is everybody's favorite normally. Guess what you get to do to figure this out? You get to do long division. Or in this case, do you have to do long division? What can you use on this if you don't want to do long division? What can you use on this specific problem? Why can you use synthetic?
Because the bottom's 1.
Bottom is a linear with 1 coefficient, right? So can you synthetically divide that, please? Please? If you're not sure what's going to go in the penalty box? -2. Now be really, really careful. What's going to go over here? Good. 1, 0, -1. I love it. So go for it. The 0 for the fact that there's 0 x's up there, right? let's see. You should be done by now. Bring the 1 down, multiply, add, multiply, add. So what's this going to be?
X minus 2 equals 3 over x plus 2.
Yes. Now. So real quick, I just want to make sure you all understand what we just did. How does this compare to f of x? How does this relate to f of x, the original function? How do they relate?
That is the answer of the x squared minus 1 divided by x plus 2.
Yeah, they're the same. They're equal to each other, right? How does 1/2 relate to 0.5? How do they relate? 1/2 and 0.5. They're the freaking same, because 0.5 is what I get when I do what 1/2 tells me to do, right? And this seems weird, just go with it. So that is the same function as that. It's just written differently. It's just I actually did the division, right? But they're the same function, correct? Somebody remind me. For horizontal asymptotes, what am I letting x do? I'm letting x get really big. Can you guys tell me what happens to this piece when x gets really big? Gets really small, so it goes to 0. It gets infinitely close to 0 if I let x get big. If x is 18 billion, that's basically 0. 3 divided by 18 billion and 2. Isn't that like so close to 0, we just go, it's basically 0. Yes? And 18 billion is nowhere near infinity. Holy shit. Right? Does it ever get to 0? Could I divide 3 by something and make it equal 0? Nope. But I can make it get as close to 0 as I want. That's the whole idea of an asymptote, right? I can make it get as close to 0 as I want. Okay. So therefore, when x gets really big, this function has to look like this. So let's see what that means. Let me show you. So when x gets really big, I expect the outputs to follow that line. And so the outputs are going to go to infinity like they should. So look what this thing looks like. Do you see how here it doesn't look like a straight line? We go straight through there? Let me put that line up here. What was it again? Sorry. X minus 2. Do you see how that's an asymptote? It's a diagonal asymptote, and that's why we call it a slant asymptote, because it's slanted. And again, math people are really creative. Oh, it's a slant asymptote. Okay, so that's a slant asymptote, right? Isn't the function coming right up to it the way it's supposed to do with any asymptote? Are you guys with me at all? A little bit? And remind me, what was the vertical asymptote again? X equal -2, right? So I could put that in here also. There, see? That wall here, it's slamming up against that wall. And this blue thing, the slant asymptote, see how it slams up against it? And it slams up against that one going that way? So look how it basically becomes that. Do you see how it basically becomes that line as x gets really big? So if I kind of zoom in here, I'll eventually see there's a difference, but they're just getting so close. That's exactly what an asymptote means. So that is the freakiest asymptote. You have the long divide so you can just see what it looks like. Maybe? So asymptotes in general, I think you all kind of get the idea of asymptotes. It's got to get really close to it. So if I have a diagonal asymptote, it's the same thing. It has to eventually get really close to it. It's a different look than what we're used to, right? It's just the wall, I just kind of make it crooked. And then, oh, shit. Maybe, okay. So I know part of it is not exciting to hear that part of these problems will sometimes be long division. Can I always use synthetic division? No, damn it. If the bottom is like x squared plus 2, can't use synthetic division. It's got to be linear. Okay. All right. Let me say one thing about where we're headed next. Let me just write something down and see what the reaction is. I'm not going to show it to you yet. Let me see. Let me write this down. Okay, here it comes. See what the reaction is. Is there a reaction? Do you guys have any reaction to this? Has anybody ever seen this before? Yeah. And you all know what the word is, but do you guys know what that's a function, and it's just a really, personally, I think it's one of the worst decisions we ever made. So like, what does this symbol mean? Square root. And what is it really asking you? What's the question that square root symbol is asking you? What times itself equals the inside, right? So do you see how math people, we don't like to write much? So we make a symbol, and the symbol could mean like a whole paragraph of information. In this case, it's just a sentence. What times itself gives you the number that's inside this symbol. That's what that means. We don't even think that, do we? Because we've internalized it so much. It's sort of like if you learn a second language, you start to get to the point where you don't have to always translate to the new language in your head. You can just kind of go straight there. I never did that, except between math and English, right? I don't have to translate for math. This does not mean the same thing as this, but they are related in the sense that we just have to figure out what sentence, what question is that asking me? So the question that is asking us is 2 to what power gives you 8? So a log really is just asking you what power the number in the base needs to become 8. Or you can think of it as how many 2's multiply to be 8. So how many 2's do multiply to be 8? So the answer to log base 2 of 8 is 3. That's it. That's what that is. The same way the square root of 9 is 3. That's the answer, right? Now, again, just make sure. Log base 2 of 8 and square root of 9 are not related. They're not equal. They just happen to both be 3. Right? But I'm trying to get you to understand, whenever you learn a new math symbol, you internalize the question it's asking you. Right? And I don't think that when students learn logarithms, they're kind of told that. It's just shorthand for a long question. So real quick, now that we know the log base 2 of 8 is asking me, what power does this need to become this? What do you guys think this is? Yeah. 2 needs a 4th power. 4 2's multiply to be 16. Bam! Right? Is that a difficult question to answer? But what's weird is you don't know that that's the question that's asking. You have to first realize, what question is this funky-ass math symbol asking me? Maybe. One more of these, and then I'll let you out of here. What's log base 8 of 64? What? Yes, why? 8 squared is 64, exactly. Okay. So that is coming up very soon. We do have one section that we sort of already done in chapter 5. So we'll finish out chapter 5 next time. Chapter 6 is logarithms. Exciting stuff. Okay. That's enough to finish. Okay.